This is our presentation, Crops Undercover, Tips and Tricks for Using Row Cover. And myself, Katie Fiske Pulliam, and Elaine Losekamp are going to be giving this talk today. So in our last OREI grant, we surveyed organic vegetable growers in 3 different regions to understand the challenges that they face. And within the top 10 of these challenges, they all fall into 3 really distinct categories of biological, climate, and economic challenges. And those top 4 challenges being insects, heavy rain events, diseases, and weeds. And our research has found that these protective row covers can be a dual solution to the challenges that growers face. In fact, 88% of vegetable growers already report using these row covers. Now, traditionally, row covers have been used in a lot of different production systems with varying sizes and types of row covers. And I'm sure most of you all are very familiar with these. But what I'm going to focus on, or what we're going to focus on in this presentation, is the use of fine mesh netting at the mid or mesotunnel and low tunnel sizes indicated in this red box. And then I know that some of you all are using these nets on high tunnels, but we're really focusing on these mid to small size tunnels. And there are also lots of different sizes of mesh materials that you can use. But our research really focuses on the 85-gram exclude net pictured on the left and the 25-gram protect net pictured on the right. So the 85-gram net is a really sturdy fine mesh netting. It's about 0.95 millimeters by 0.95 millimeters. And the mesh size is small enough to exclude insects like cucumber beetles, squash bugs, potato beetles, stink bugs, spotted wing Drosophila, and caterpillars. Although with the caveat that if you have a bunch of caterpillars that come up from the soil, then they may actually get trapped underneath the net. The 25-gram Protect net on the right is a stretchier fine mesh material, kind of similar to pantyhose. And this mesh size is much smaller than the 85-gram net, so it's going to exclude all of the same insects, and it will also exclude flea beetles. And real quickly, I just wanted to note that this 85-gram and 25-gram, the grams is not necessarily related to the mesh size. It's related to the weight of the material. So it's just however many grams per square meter of material. So from that same survey that I mentioned earlier, we asked growers what benefits they believe protective row covers can provide. And almost all of them agreed that row covers are really beneficial for reducing vulnerability to weather. They can reduce insecticide use. And then they also agree that they improve produce quality and yield. And we have a lot of evidence from some of our past research that row covers do, in fact, increase yield relative to organic insecticides for a large number of crops. But what growers really disagree on is whether they can reduce input costs. And they aren't really necessarily wrong. So the upfront costs of purchasing these 2 nettings that I mentioned we've been using are quite high. So between $1,200 and $1,600 to buy 1 roll that would cover 328 feet by 26 feet. So we have some questions. Does the yield benefit outweigh this upfront cost? Are there different strategies that we can use to decrease this cost? And so one of these potential strategies is to decrease costs by using or reusing these materials multiple times. So perhaps with 3, 5, or 15 uses, we could lower our cost to $100. Although we do have some questions on whether the 25-gram can make it to 3, 5, or 15 uses. And so this is where our Crops Undercover team steps in. This is a multi-state collaboration between Cornell, Iowa, UK, and the Organic Center. And this pictured here is our UK team, where we are really focusing on these challenges and questions that we have. So the overarching project objectives of the Crops Under Cover team are to determine what crops benefit the most from pest and climate protection, to evaluate and optimize the cost effectiveness of these pest protection systems, to really understand organic farmer, consumer, and industry perceptions of row cover protection systems by using surveys. And then the last part is outreach. So we want to be able to communicate these new findings to farmers, consumers, and industry. For the purposes of this presentation, we're really going to focus on what crops benefit the most and the outreach component, which is what we are doing right now. So just to give you a little bit of a framework of how we would reuse these row covers during the growing season, you would start with your spring crop that you'll go ahead and cover, and then you'll plant that summer crop, and then move that same piece of material to your summer crop, and then you'll plant your fall crop, and then move that row cover to the fall crop so that you're using one row cover material through 3 different crops in a growing season. And this is what we did for this year's, well, 2024's research. So we rotated those row covers through a spring, summer, and a fall crop. So we've already used it 3 times out of the potential 9 times that we could be using them if we do this project for another 2 years. So I'm going to pause and let Elaine take over for this next part.
Thanks, Katie. So now I'll start talking about our row cover trials that we did at the University of Kentucky Horticulture Research Farm in 2024. And I'll go over the crops that we trialed row covers on, some of our results, and then some general tips and tricks about using row covers for pest protection. And I'll finish up by talking a little bit about the microclimate research that our lab is doing with row covers. So we looked at a variety of different crops in 2024. And for each season, we had a main crop that we looked at. And I'll go into a little bit more discussion in a moment about the distinction between main crops and pilot crops. But just to list out what those were, our main crops in spring, summer, and fall were bok choy, eggplant, and Napa cabbage. And then we also had pilot crops for green beans, bell peppers, basil, watermelon, cucumbers, patty pan squash, and Brussels sprouts. So our main crops were the focal point of our research program, and we grew these crops on a large scale. We looked at 4 different pest management treatments for each of these experiments, which included 2 different row cover configurations, an organic insecticide rotation, and then a control where we didn't spray organic insecticide or use a row cover. And for each of these experiments, we devoted an entire 300-foot long by 50-foot wide field to the experiment, which we then divided into 4 blocks. And inside each block, we randomly ordered the 4 treatments. And so this picture at the bottom of the screen is an aerial view of our eggplant summer experiment. And the orange section shows 1 block with the 4 treatments inside of it. And each treatment was in a 30-foot long plot that contained 3 beds of crops. And for our row cover treatments, we had 1 piece of row cover material that completely covered that 3-bed wide, 30-foot long space. Our experimental design for our pilot crops was a lot smaller. For our pilot crops, we just looked at a row cover treatment and an uncovered control. And for these crops, we just had 1 replication of each treatment for the majority of them. There was a little bit of variability with size, but generally these were the same 30-foot long by 3-bed wide plots. And this picture on the right shows our bell peppers right after planting, and the controls at the front with the row cover behind it. So what did we find? We saw that across almost all of our crops, row covers increased yield relative to the control. So as you can see at the top of this graph, the eggplant was the crop where we saw the biggest increase in yield relative to control. And for that crop, we actually saw that the row cover had a yield that was 16.6 times higher than the yield from the uncovered control. And a couple things that I want to point out about this graph are that, as you can see, there's a large amount of variability in the difference between the yield from the row cover and the yield from the control. Um, Towards the bottom of the graph, we saw that the yield from the row cover treatment and the yield from the control treatment were almost exactly the same. But then for a lot of the crops higher up on the graph, we saw a big difference. And I also wanted to point out that these results are just from 2024 and just from our experiment at the UK South Farm. So if we were to replicate these experiments again, we might see a little bit of difference. But with all of that being said, as you can see from this graph, using a row cover can increase yield a lot compared to using no row cover at all. So I'm going to spend the next couple minutes talking about our highest performing crop groups, which were cool season brassicas and warm season eggplant and cucurbits. And these were the crops where we saw the biggest improvement in yield from using a row cover. So to start out, we grew bok choy in spring 2024. And for this experiment, we compared a control with no row cover or insecticide to an 85-gram row cover, an organic insecticide rotation, and then a combination of an 85-gram row cover with organic insecticide applications. And something important to highlight about this crop is that we had a lot of impacts from flea beetles, which are a major pest of brassica crops. I want to point out that we actually had no yield at all from our control treatment because the flea beetles caused so much damage to the crops that we weren't able to get any marketable heads of cabbage from that treatment. The row cover alone and insecticide alone treatments had somewhat similar yields, although the organic insecticide outperformed the row cover. And we saw that combining a row cover and an organic insecticide rotation actually more than doubled yield compared to just using insecticides. Just to give you a visual, on the left side of the screen, we have a typical bok choy from the control treatment, and then on the right side of the screen is a typical bok choy from the combined row cover and insecticide treatment. So as you can see, there's a big difference in the amount of damage from flea beetles between these two treatments. Just to go into a little more depth about flea beetles, they are a major pest of brassicas, and they can introduce some challenges with row cover use for a couple different reasons. One of these is that these beetles overwinter in crop residues and the soil. And so if you aren't practicing crop rotation and you plant brassicas in the spring in the same location where you had brassicas growing in the fall, you can have these beetles emerge from the soil under a row cover and cause a lot of damage to your crops. And then something else important to note is that these beetles are extremely small. They're about a quarter of an inch long. And so the type of row cover that you use is really important because if the mesh size is too big, the flea beetles can be able to move through the row cover and then access your crops. And that is exactly what happened to us in the spring. We used the 85-gram row cover because we thought it would be able to keep the flea beetles out, but it turned out that flea beetles were able to move through the holes in the row cover and access the plants, which caused a lot of damage to our row cover treatment. So moving forward in the fall, we decided to start using a 25-gram row cover for our Napa cabbage. And in 2025, we'll use both an 85-gram and 25-gram to compare the two row covers. But I wanted to highlight that there are definitely a lot of trade-offs between the different types of row covers that you can choose from. With these two, the 85-gram and 25-gram, we found that the 85-gram is a lot more durable. We, as we mentioned, have been using the same row covers across 3 seasons. And so we had several 85-gram row covers that were out in the field from April until the end of October last year. And with these row covers, they really didn't get any damage, whereas we had 25-gram row covers in the field for just about a month. And we already saw some big holes and rips, as you can see in this picture to the bottom right of the screen. So when you're choosing whether or not to use row covers, it's important to think about the type of crops that you would be growing and the type of insect pests that you might see, and that will influence what type of row cover might be most appropriate. Moving on with our brassicas, we grew Napa cabbage in the fall of 2024. And here we compared a control to an organic insecticide rotation, and then the two different types of row covers that I just mentioned, the 25 and 85 gram. For this, we saw that the 85-gram row cover had the highest yield. It actually increased yield relative to the control by 4.7 times. We saw that there was really low flea beetle pressure in the fall, but we had a lot of army worms that came and damaged a lot of the crops in September. And so that caused a lot of damage, especially to the control. And one thing that I wanted to note is that the row cover treatments, the plants in those treatments were actually ready for harvest about 1 week earlier than the plants in the uncovered control and organic insecticide treatments. And so that's a promising indicator that even outside of pest protection, there are a lot of other benefits to using row covers, like speeding along plant growth. And moving on to our other crops, the other highest performing crops that we saw were eggplant and cucurbits. But one thing to note about these crops is that they are pollinator dependent, and row covers exclude not only insect pests, but also insect pollinators. And so that raises the question, how do you manage pollination if you're using a row cover that's keeping insects out? And so we have seen that there are a variety of different solutions that can be done. These include stocking a row cover system with commercially purchased bees, opening the ends of the row cover at flowering, which is shown in this photo to the left, completely removing the row cover at flowering, or using parthenocarpic varieties of crops that don't require pollination. And in our lab, we have tried stocking the row cover with bees, opening the ends and removing row covers entirely at flowering, and we intend to do research with parthenocarpic varieties in the future. But for all the results that I'm talking about today, we opened the ends of the row covers at flowering, and we saw good results, both in terms of reducing pest pressure and allowing for pollination. So with eggplant, we wanted to look more closely at the difference between removing a row cover entirely at flowering and opening the ends to see if that impacted yield. And so we compared these two strategies with an 85-gram row cover to the control and an organic insecticide rotation. And we saw that it made a big difference to have a full season row cover with open ends. The yield from that treatment was more than twice the yield from the treatment where we removed the row cover at flowering, 6.8 times greater than the organic insecticide, and then 16.6 times greater than the control. So we saw that the open-end strategy was very effective with this crop, and that using row covers was very effective when compared to having no row cover at all. So while we've seen that row covers can have a lot of really big benefits for crop production, there are also a lot of challenges that we should highlight. And this isn't an exhaustive list, but just some of the challenges that our lab has discovered while working with row covers. So to start off, aphids can be a big problem when you're growing things under row covers. If aphids are able to move under the row covers and reproduce without natural enemies present, they can quickly expand their population and become a big problem. As we've discussed before, cost and labor requirements can be high for row covers. Then there are also issues with non-vector diseases like powdery mildew. There's also a lot of variability with different crops that grow under row covers, as I've mentioned. You might grow a crop under a row cover and not see any yield improvements at all, or you might see very large yield improvements. And then there's also some challenges with weed management and with weather events and row covers. However, there are definitely solutions available to us. With aphids, we see a lot of promise with using biological control agents, so purchasing insects like, for example, lacewings, and then releasing them under the row covers for aphid control. Cost might be decreased if you're able to reuse your materials, as we're looking at with our research. And then while non-vector diseases could potentially be higher under row covers can also exclude vectors like spotted cucumber beetles, and so you might have fewer issues with diseases if you're using a row cover. And then I'll go into a little more detail with weed management and weather events. So for weed management, that's one of the bigger problems that we've run into while using row covers. In our system, as I mentioned, we have one row cover over 3 beds of crops. And so in the furrows between those beds of crops, we have to figure out ways to manage the weeds. And so we wanted to look at the best way to manage weeds in the furrows in terms of reducing pest pressure, increasing yield, and reducing labor costs. And so for 2024, with our 3 main crops, we tried out 3 different weed management treatments in a separate experiment under row covers. And so for the bok choy, eggplant, and Napa cabbage, we tried landscape fabric, the bare ground control, where we let weeds grow, and then a cover crop in the furrows between beds of crops. And for our spring bok choy, we used a perennial ryegrass cover crop. And then for the summer and fall eggplant and Napa cabbage, we used a teff cover crop. And in this experiment, we found that in the cool season, there wasn't a big difference with weed management between these 3 different treatments. Ultimately, the plants didn't grow very quickly in the furrows, and so we didn't see that we had to do additional weed management, and the cover crop and weeds didn't really impact the yield for the main crop. However, in the summer, the weeds and the cover crop both grew quickly, and we had to do mowing under the or in the furrows, which introduced a lot of labor because you have to either mow under the row cover or completely remove the row cover and all of the sandbags that are weighing the row cover down. And so that can be a bit laborious. However, we did find with our eggplant in the summer that using landscape fabric not only effectively suppressed weeds, it also actually increased the yield of the eggplant relative to the bare ground and cover crop treatments. And so we're seeing that that might be a viable strategy for weed management for summer crop production. And then I also wanted to highlight extreme weather events. So as I'm sure you all know, there have been a lot of extreme weather events in Kentucky over the past couple of years. And we wanted to know with our research whether using row covers allows us to mitigate some of the impacts of that extreme weather on our crops. And so to test this out, we implemented weather stations in our main crops across the 3 seasons. So we had a selection of weather stations in the control out in the open field. And then we also had weather stations under the full season 85-gram row covers. And we continuously collected data with those weather stations from April until the end of September. And we found with the weather stations that the row covers were able to provide protection and a buffer for the crops. So for instance, to illustrate this, I'm sure you all remember Hurricane Helene back in September. So we had weather stations out in our field of Napa cabbage when the hurricane hit. And this graph on the left of the screen shows the mean wind speeds from the weather stations during that event. So that top blue line shows the mean wind speed from the weather stations that were in the uncovered control treatments. And then the bottom orange line shows the wind speed from the weather stations that were under the 85-gram row cover. And we saw that there is a huge difference and that having the row covers over the weather stations actually decreased the average wind speed by 3 times. And we saw a difference in the peak wind speed. In the uncovered treatment, it was as high as 30 miles per hour, whereas under the row cover, the peak wind speed only reached 13 miles per hour. So that just goes to show that even outside of pest protection, there are definitely other benefits to using row covers as well. And we're looking forward to exploring this with our research in the future. And that's about all the time we have today. So I wanted to thank everyone in the Gaungathere Agroecology Lab, the UK Horticulture Research Farm, and the UK Entomology Department, as well as our funders with the USDA and our partners with Cornell, Iowa State, and the Organic Center. And I also wanted to thank you all for listening to our talk and encourage you, if you have any questions, to reach out. We have our emails up on the screen, and then our outreach website for our Crops Undercover project is listed as well, in addition to our YouTube and Instagram channels. And you can also scan that QR code to be directed to our website. So thanks again, and please reach out if you have any questions.